In this video, we're going to talk about throughput capacity for reads and writes in DynamoDB. When you create a table or index in DynamoDB, you have to specify your capacity requirements for read and write activity. By defining your throughput capacity in advance, DynamoDB can reserve the necessary resources to meet the read and write activity your application requires while ensuring consistent, low latency performance. You specify throughput capacity in terms of read capacity units and write capacity units. One read capacity unit represents one strongly consistent read per second, or two eventually consistent reads per second, for an item up to 4 kilobytes in size. If you need to read an item that's larger than 4 kilobytes, DynamoDB will need to consume additional read capacity units. The total number of read capacity units required depends on the item size and whether you want an eventually consistent or strongly consistent read. One write capacity unit represents one write per second for an item up to 1 kilobyte in size. If you need to write an item that's larger than 1 kilobyte, once again, DynamoDB will need to consume additional write capacity units. The total number of write capacity units depends on the item size. And just very quickly, the difference between a strongly consistent read and an eventually consistent read is that with a strongly consistent read, when you request one, DynamoDB returns a response with the most up-to-date data reflecting the updates from all prior write operations that were successful. Whereas with eventually consistent reads, when you read data from a DynamoDB table, the response might not reflect the results of a recently completed write operation. The response might include some stale data. If you repeat your read request after a short time, though, the response should return the latest data. So back to throughput capacity, let's say, for example, that you create a table with 5 read capacity units and 5 write capacity units. With these application settings, you could perform a strongly consistent read of up to 20 kilobytes per second, which is 4 kilobytes times 5 read capacity units. Or you could perform eventually consistent reads of up to 40 kilobytes per second, which is, of course, twice as much. And then finally, you could perform writes of up to 5 kilobytes per second, which is 1 kilobyte times 5 write capacity units. For more practice and information, I definitely recommend going to your DynamoDB dashboard and finding the capacity calculator, or just doing an online search for throughput capacity and capacity calculators. If your application reads or writes larger items, up to the DynamoDB maximum item size of 400 kilobytes, then it will consume more capacity units. If your read or write requests exceed the throughput settings for a table, DynamoDB can throttle that request. It'll also throttle read requests exceeds for an index. Throttling prevents your application from consuming too many capacity units. When a request is throttled, it fails with a 400 code. You can use the Management Console to monitor your provisioned and actual throughput and to modify your throughput settings if necessary. DynamoDB provides the following mechanisms for managing throughput: autoscaling, provision throughput, and reserve capacity. DynamoDB autoscaling actively manages throughput capacity for tables and global secondary indexes. With autoscaling, you define a range of upper and lower limits for read and write capacity units. You also define a target utilization percentage within that range. DynamoDB autoscaling seeks to maintain your target utilization even as your application workload increases or decreases. With DynamoDB autoscaling, a table or a global secondary index can increase its provisioned read and write capacity to handle sudden increases in traffic without requesting throttling. When the workload decreases, DynamoDB autoscaling can decrease the throughput so that you don't pay for unused capacity. Note that if you use the AWS Management Console to create a table or a global secondary index, DynamoDB autoscaling is enabled by default. The second throughput mechanism is provisioned capacity. If you aren't using DynamoDB autoscaling, you have to manually define your throughput requirements. Provision throughput is the maximum amount of capacity that an application can consume from a table or index. If your application exceeds your provisioned throughput settings, it's subject to request throttling. For example, suppose that you want to read 80 items per second from a table. The items are 3 kilobytes in size, and you want strongly consistent reads. For this scenario, each read requires one provisioned read capacity unit. To determine this, you divide the item size of the operation by 4 kilobytes and then round up to the nearest whole number. Let's take this example. You take 3 kilobytes, divide that by 4 kilobytes, which comes out to 0.75 or 1 read capacity unit after you round up. For this scenario, you have to set the table's provisioned read capacity throughput to 80 read capacity units, which is 1 read capacity unit per item times 80 reads per second, or 80 read capacity units. Now suppose that you want to write 100 items per second to your table, and that the items are 512 bytes in size. For this scenario, each write requires 1 provisioned write capacity unit. To determine this, we divide the item size of the operation by 1 kilobyte and then round up to the nearest whole number. So we take 512 bytes and divide that by 1 kilobyte, which comes out to half a kilobyte, and then round it up to 1. For this scenario, we'd want to set the table's provisioned write throughput to 100 capacity units, or 1 write capacity unit per item times 100 writes per second. And the final throughput mechanism is reserved capacity. As a DynamoDB customer, you have the option of purchasing reserved capacity in advance. With reserved capacity, you pay a one-time upfront fee and commit to a minimum usage level over a period of time. By reserving your read and write capacity units ahead of time, you realize significant cost savings compared to on-demand provision throughput settings. And that'll wrap it up for our video on DynamoDB throughput capacity. So if all of that made sense, then feel free to move on.